Welcome dear students. Today we will tell you about the simplex method in the book Operation Research. So first question arises why we need another method whereas we are solving the linear programming problems by graphical method. It is a realistic, graphical method is realistic, but it can be applicable only for two variables. By plotting the graph, we can solve such type of linear programming problems in which only two variables involved. But in a realistic world, there are so many problems which involves more than two variables. So we need another method to solve such type of problems. So we introduce simplex method. In this method, we use some basic definitions, such as first of all you have to know about the select variables. In the constraints of a linear programming problem, there involves inequalities, whether they are of less than or equal to or greater than or equal to or equal to. Three types of inequality involved. When in a constraints, inequality less than or equal to involves, then to introduce equal sign, we subtract a non-negative variable in the inequality in the left hand side. That variable is called slack variable. We are given a simple example. If x1 plus 2x2 plus x3 less than or equal to 4, since the inequality is less than or equal to, so we add a variable in the left hand side of this inequality. This inequality changes into equality. It becomes x1 plus 2x2 plus x3 plus xb1 is equal to 4. This xb1 variable which we have added in the left hand side of the inequality is called slack variables. Now another variable, surplus variable. When an inequality greater than or equal to involves in a constraint, convert it to equality, we subtract a variable in the left hand side of the equation which is called surplus variable. Suppose equation you have to give in x1 minus 2x2 plus 3x3 greater or equal to 6. Then to convert it in equality, it becomes x1 minus 2x2 plus 3x3 minus s1 is equal to 6. This variable introduced or subtracted in the left hand side of the equation is s1. This s1 variable is called surplus variable. Some basic definitions we are telling you which plays important role in the procedure of simplex method. First of all, basic solution. A solution of this system n by m equations, n variables, m is less than n, by setting n minus m variables equal to 0 is called a basic solution, provided that the determinant of the coefficients of remaining m variables is not equal to 0. Such m variables are called basic variables, and the remaining n minus m variables are called non-basic variables. Now we will give you a systematic procedure to solve a linear programming problem by simplex method. The following steps are used. In step first, if the given problem is or linear programming problem is of minimization, then convert this problem into maximization problem. In the linear programming problem, the objective function, if it is minimum of z is equal to x1 minus 3x2, then take another function z dash which is equal to minus z is equal to what it will become? It will become minus x1 plus 3x2. Obviously, maximum of z dash is equal to minus minimum of z. So, what is the first step? In first step, we will, if the problem given to us is a problem of minimization, then we will convert it into the problem of maximization. Now we come to inequality. Ax less than or equal to b. In matrix form or in simple form, inequalities are written as Ax less than or equal to b. In the second step, we make all bi's is non-negative. Means if in any inequality, if some b1 is negative, then multiply this inequality by a negative sign. Then equality will also revert and bi will becomes positive from negative. For example, if 2x1 minus 5x2 greater or equal to minus 7. Since this b1 is negative, minus 7, so in the process of simplex method solution, we convert this b positive by multiplying minus sign in the whole inequality. So inequality will also reverse. So this becomes minus 2x1 plus 5x2 less than or equal to 7. So in the second step, we convert all bi's are positive or non-negative if someone is negative. Now we convert the inequalities into equation by adding slack and surplus variables. We have already told you about the slack and surplus. And next step, we will find the initial basic feasible solution. First case, simplest case, if only slack variables are involved in the problem in constraints of n variables, then suppose the variables are x1, x2, x3, xn, and the surplus variables are s1, s2, s3, sn. Then put these n variables, non-basic variables, x1, x2, x3, xn is equal to 0. Then simply we find the initial basic solution in which we get the values of basic variables, means values of slack variables. It comes out s1 is equal to b1, s2 is equal to b2, S3 is equal to B3 and Sm is equal to Bn. If the surplus and artificial variables are also used in some constraints, then obtaining the initial basic feasible solution, put the given decision variables and surplus variables equal to 0. Means if the now one term which I have used, artificial variables. When a inequality is given in the form of greater than or equal to, then we told you that we introduce surplus variable to convert it into equal to. But to converting it, there is no basic variable. Basic variable means which forms a basis, means it involves unity. So in such type of constraint, we use or add or introduce another variable. Why? To form basis. This variable is called artificial variables. Here I have told you that if the inequality is x1 minus 2x2 plus 3x3 greater or equal to 6, to convert it into equality, we introduce a surplus variable minus s1, and to form a basis, we introduce another variable s. This s variable is called artificial variable. Now, to construct initial simplex table, and note that the variables, select variables which we introduce in the inequalities to convert into equality, put the cost value 0 in the objective function, and all the variables are satisfying the condition of non-negativity. Now we form a first simplex table or construction of starting simplex table. See here, we form a table. In first column we write basic variables, means select variables, basic variables which form basis in the constants. Write the basic variables. In the second column, write its cost values from objective function. So if the problem is of only select variables, then in the starting simplex table, all the CVs are 0 because we introduce all cost of all select variables in the objective function 0. XB, the initial basic feasible solution, means value of select variables when all decision variables are put 0. XB1, XB2, XB3, dot dot dot. Here we are forming or explaining you a simplest form table of 3 variables only. So in third column we write XB, values of basic variables. Then Y1 means coefficients of x1 in the constraints, y2 the coefficients of x2 in the constraints, dot dot dot, and s1 the values of the coefficients of select variable. These s1 s2 forms basis, mean it will be in the form 1 0 0 0 1 0 and 0 0 1, forming 3 equations problem. In the next step, write upper side Cj means C1, C2, C3, dot dot dot. These values are taken from the objective function maximize z is equal to Cx, where C means C1, C2, C3, dot dot. Now we find z is equal to Cb xb and we find the delta j. The formula used for finding the delta j is we use delta j is equal to Cj minus Cb by j. In the simplest problem, when only slack variables are involved, these comes out in the starting simplex table. Delta 1 comes out C1, delta 2 comes out C2, delta 3 comes out C3, and all the deltas corresponding to the basic variables comes out to be 0. In the all values of delta, we select the maximum value of delta j in which column exists. Suppose if delta k is maximum, then yk will be the incoming vector. Here we are explaining if delta 2 is maximum. Delta 2 is max, delta 1, delta 2, delta 3, dot dot dot. Then delta 2 will be incoming vector. If delta, in generalization, if delta k is maximum, then yk will be incoming vector. Now we find the ratio of xb upon yk. After finding this ratio, we find out which is minimum, means minimum in xb upon yk. If this value, then the minimum value, that row will be outgoing vector. Suppose if the second row value is minimum, then comes out to be this type. This basic variable, suppose it is y2, then suppose it is y1, then this will be outgoing vector. Draw the lines from outgoing vector and incoming vector at which element they intersect. This element is called key element. This element is called key element. Now we convert the key element unity and other elements of that column 0 by the operations usually we use in matrices. So first simplex table is complete. Then we form revised simplex table. What will be the change? Here, in the basic variables, the remaining variables will remain same, but the in place of outgoing vector, we introduce incoming vector, and in CV, the corresponding cost of incoming vector. And then operation is performed in this row. Suppose if this key element is 2, then divide this row by 2 to find the unity in place of key element, and then for this incoming vector row, the basic form means 1 0 0 or 0 1 0 or 0 0 1. Again we find delta j. If all delta j's are less than or equal to 0, then our solution is optimal. If they are all not less than or equal to 0, then again same process will repeat. means we select the maximum value of delta j, in which column it exists, that will be the incoming vector. After finding incoming vector, we again find the xb upon yk, where yk is incoming vector, find the minimum values for the corresponding rows, then the, that minimum value corresponding row will be outgoing vector. Again, same process we repeat continuously till all delta j comes out to be in the form all delta j less than or equal to 0. Then in that case, we will get the optimal solution of the linear programming problem by the simplest case of simplex method. Okay, and in the next time we will solve or we will explain this simplex method by a example, step by step. First you have understand the procedure theoretically, and in the next lecture we will explain this whole procedure by taking a simple examples by which you will be able to understand every steps in example. Okay, so study this method, and if any doubt, then I will clear you in the next lecture in which we will explain this whole simplex method by example. Thank you very much.